In this video, I'm going to be examining a variety of ways to build a rhombus. On each of the 11 pages of this Web Sketchpad model, you'll find a small collection of tools. We're going to use those tools to build a rhombus. On some of these pages, the tools will allow you to build a very robust rhombus, meaning that if you drag a vertex of the rhombus, it will change its size and shape, but always maintain 4 equal sides. On other pages, you'll be able to use the tools to build a rhombus, but when you drag a vertex of the rhombus, you might discover that the rhombus changes its side lengths, for example, but always maintains the same angle measurements. So let's get started. On page 1, we have an equilateral triangle and a point tool. And I should note that the point tool is here primarily to help you mark the vertices of your rhombus as you're constructing it. So what can I do with an equilateral triangle? Well, let's get started and just make one. I'll tap the tool icon, and I see a preview of the equilateral triangle that I'm about to construct. And one of its vertices is glowing, indicating that I should place it somewhere. So I'll just tap here to place that vertex. Now the other vertex is glowing, and I'll tap, say, here to place it. And my tool is complete. I now have an equilateral triangle, and if I drag either of these red points, I can change its size and orientation. So let's see, if I want to construct a rhombus, here I have 3 sides that are all equal, and maybe I can use this side and this side as 2 sides of my rhombus. So let's construct another equilateral triangle, and I'm going to attach it to this existing one. So I'll tap this vertex of my existing equilateral triangle to merge these 2 points together, to attach them. And now this point that's glowing, I'll tap this vertex of my original equilateral triangle to attach them together. And there. Now when I drag either of these points, I see that my 2 equilateral triangles are attached. And I see a rhombus, these 4 sides. And how can I check? Well, on each page we have a quadrilateral ABCD sitting here in the corner. And if we attach it to our supposed rhombus, the vertices of it, we can check to see if it's a rhombus. So I'll start with point A, and I'll drag that here to this point. And when it glows, I'll let go. And now these points are attached. And I'll continue that with the remaining 3 vertices of ABCD, attaching them to my supposed rhombus. And finally, point D. And not only have I constructed the interior of this quadrilateral, but I see that it is indeed a rhombus. And I see that when I drag it, it looks like it maintains 4 equal sides, and that's because I'm dealing with equilateral triangles that I just built that have equal sides. But notice that its angles do not change. I have 60, 60, and 120, 120. So this is a rhombus, but not a very robust rhombus. So that's page 1. Here on page 2, we're given a circle by center and radius and a point tool. Well, let's see what the circle by center and radius does. If I tap on it, I see a portion of a circle and what looks like the center point glowing. So I'm just going to tap to place that circle, and my tool is complete. If I drag this center point, I can translate the circle. I can drag it here by its circumference, but the circle doesn't change size. So let's see what this segment does. If I drag that, notice what happens. This segment is actually the radius of the circle. It controls the circle's size. So what can I do with this? Now I should note that when I'm showing these solutions, I'm going to jump pretty quickly to a construction that builds a rhombus. When you're using this with students, things will not be nearly, I think, so direct. So I'm going to back up a step here, and this time when I build my circle, I'm kind of tempted to attach it to this endpoint of the segment so that the segment really looks like a radius of the circle. And now let's build a second circle. I'll attach it to this endpoint. And I now have these two interlocking circles that share the same radius. And if I construct a point here at this intersection of the two circles and here at the other intersection, it looks to me like these 4 points, because of the fact that these two circles share the same radius, are going to make a rhombus. Again, it looks like it's not going to be a very robust one. It will have 2 angles that are 60 and 2 angles that are 120, but it is a rhombus, and it introduces us to the idea of interlocking these two circles together. I'm not on these subsequent pages here going to actually spend the time attaching A, B, C, D. To check, that's something that you can do yourself. On the third page of our web sketch, we're again given the same tool, the circle by center and radius, but here the segment that determines the radius is sitting in the bottom left corner, and I can't move it up. So if I want to use the same strategy as before of attaching the center point to an endpoint of this segment, the problem with that is I can't see the entire circle. So let's just make this circle anywhere here in the sketch so I can see the entire circle. And let's make another circle. I could attach it to the circumference of this first circle by tapping. That would essentially get me back to where I was before. Let's try something a little different though. Let's place this circle just any old place here in the sketch. And now I can drag this circle to intersect with the first one. These two circles always have the same radius, which is determined by this segment. And I can, as before, place points where the circles intersect. And this gives me a rhombus defined by these 4 points. I should note that if you want to, you can label them by using the text widget. And this is a more robust rhombus. I'm not always restrained to those same angles as before of 60 and 120. So E, F, G, and H form a rhombus. But when these circles are far enough apart, the rhombus collapses. So it's a robust rhombus with some issues at the extremes. Now we are on to the fourth construction. Here again, we're given a tool that constructs a circle, but this is just a compass tool. And let's see how that's different. I'll tap its icon, and we see a preview of a circle, and its center point is glowing. I will tap anywhere to place it, and now a point on the circumference is glowing. I will tap anywhere to place that. And here we have our circle, and unlike the previous ones, here I have a point on the circumference that allows me to change the circle's size, and I can also change the circle's size by dragging its center point. As before, I could build a second circle, and I'll attach the center of this second circle to the point on the circumference, and I'll attach this point here on the circumference to the center of my circle. And I might even want to, for purposes of making this easy to talk about, use the style widget to change the color of the second circle to blue. So my blue and green circles intersect, they interlock as before, they share the same radius, and if I marked this intersection point here and this one here, I would have that familiar rhombus we saw before, which is a rhombus, but has angles that are constrained to 60 and 120. So is there anything else we can do? Well, let's construct one more circle, I'll pick a point on the circumference of my original circle, the green one, attach the circle's center to that, and I will attach this point that's on the circumference to the center of my green circle. And let's change the color of this circle. We'll make it red. Now, if I look where the red and blue circles intersect, let's place a point there. And if I look at, let's label some points using the text widget, E, F, G, and H. If I look at these 4 points and the fact that these circles are interlocked, I can see that they actually do form a rhombus, and a more robust one than I could get if I just used 2 circles. And again, you can check this by attaching A, B, C, D to E, F, G, and H, and thinking about why this is a rhombus. For construction 5, we are given a parallel tool that creates parallel lines. And that seems like it would be useful since the opposite sides of a rhombus are parallel. So I'll tap on this, and I see a segment and a line passing through a point, and this line is parallel to my segment. And this one we have to think about a little bit about how to attach and use this segment and parallel line in conjunction with this circle that we're given. Notice actually that unlike the prior sketches, let me just turn off the parallel tool for a second, we're actually given this circle to start with. We can't build more than one, we just have this one, but we are going to use it somehow. So back to the parallel tool, and let's see, first we have to figure out where to place the segment. I'm going to think about it as a radius of this circle, so I'll attach one endpoint to the center and the other to this point on the circumference. And this point that's glowing, let's attach it to the circumference of the circle. So now I have what I think will be one side of my rhombus, and this other side of the rhombus will sit on this line. And since a rhombus is comprised of 2 pairs of parallel opposite sides, let's construct another pair of parallel lines. Again, I'm going to attach this segment to the center of the circle and to this point that sits on the circumference of the circle and passes through the line. And then this point I'm going to attach here. So you'll see that I have here, if I use the point tool, 4 vertices that comprise a rhombus. You can think about why. And it looks like it's a fairly robust rhombus. When I drag this point, I can change the size and shape of it. And I should mention here that we have some extra construction parts, which we've had before, and I probably should just show here how we can hide them. If I use the visibility widget and tap on that, I can now tap on the objects I'd like to hide. So let's hide the circle, and let's hide these lines. I'll tap here again, and they're hidden. And now I can, as I've done before, attach A, B, C, and D to the vertices of what I think is my rhombus, letting go when the points glow. And yes, I have a rhombus, and by dragging its vertices, I can change its size and shape. And if I want to see what's hidden, I can click on the visibility widget, and if I tap on any of these gray objects again, it will bring it back into view. For construction 6, we're given a translate tool, and let's see what that does. If I tap it, I see that I have a point that's glowing. I'll tap anywhere to place it, and that also moves this other point with it. And now I have another point glowing that looks like it's the tail of a vector. So let's tap to place that. And now the head of my vector is glowing. I'll tap anywhere to place it, and my tool is complete. So I have this vector, and if I drag its head, that moves this point. And let's give these points names. So I have E, F, G, and E prime. So F and G form a vector, the head and tail, and that determines the translation of point E. And notice when I look at these that these 4 points, E, F, G, and E prime, they form what seems to be a parallelogram, and you can think about why. So the parallelogram is close to what we want. It has opposite sides that are parallel, but we don't have 4 equal sides. So let's see if we can use the circle that we're given to help us out. I'm going to drag to merge F to the center of the circle, G to this point on the circumference. And as for point E, well, I want EF to be the same length as FG, so I'm going to attach it to the circle. And here I claim, and we have to think about why, these 4 points form a rhombus. For construction 7, our sketch comes with perpendicular lines. How might I use these to help me to construct a rhombus? Well, a rhombus, I recall, has diagonals that are perpendicular bisectors of each other. So maybe that's where this perpendicular comes into play. And if I can figure out locations along these lines that allow them to be my diagonals and to bisect each other, then I think I will have my rhombus. And my compass tool can help with that. So I'll tap on that, and for this first circle, I'll construct its center to pass through where these lines intersect. And for the point on the circumference of the circle, well, let's match it up with this point that's already here. For my second circle, I'm going to make 2. I'll again start by placing its center where the lines intersect. In this one, I will place the point on the circumference any place along this line here. And now if I use my point tool to mark where the circle intersects this line, and let's see where this smaller circle intersects this other line, I claim that these 4 points, E, F, G, and H, that those form a rhombus. And again, in thinking about why, think back to the properties of the diagonals of a rhombus. So now we've done 7 different rhombus constructions. There are 4 more that remain, pages 8, 9, 10, and 11. I will leave these to you to figure out. And if you're viewing this on YouTube, you can look below and see the link back to our Sign of the Times blog post where this web sketch is available. We would love to hear how you use it with students. If you or your students came up with constructions that perhaps are not the same as what I've shown here on the first 7 pages, you can leave those comments on our blog. And on our blog, you will find many other Web Sketchpad models, many that include tools, and you can learn about Web Sketchpad there, and we hope to hear from you soon about how you are using this software.